Okay, welcome all of you. Let us see today continuous being, and we will see the Clapeyron's theorem of the moment today. So, can you able to see this continuous being is written as well as can you able to listen? In that case, just type yes or no. Anyone can just type in the chat box yes or no. Okay, so let us start with the continuous being today. So, in earlier videos, we have gone through the fixed being. Now, also, we have gone through the thinking of the support, how to solve that problem. Continuous beam, when we say that which is supported other than two support, that is called as a continuous beam. And whenever it gets loaded, suppose if you just take an example that this is a beam here which has more than two supports. So we can say that this is a continuous beam having support at A, B, and C. So these are the three supports those are resting on the beam, and that is the reason we call it as a continuous beam. So whenever these kind of beams are loaded, they will deflect in the form of a curve. And in that case, at the intermediate support, the slope of the elastic curve, suppose this is the intermediate support, and if we just consider the slope of that particular elastic curve for the two span will be the same. If we just consider this as the deflection, this is a deflected shape. Now, if we just consider the slope, okay, so if we just draw this, just like, if I just draw a tangent over here, in that case, so this one is there and this one is there. Suppose if we just consider this as Z1 and this one as Z2, in that case, let us consider this as span L1 and this is the span L2. So in this case, what happened that the slope at the elastic curve for the two span will be same. And in that case, the intermediate support at the intermediate support, there we can consider that there would be no any kind of bending moment. So if there is no any kind of bending moment, so in that case, suppose if we just consider that at the end support, these are the end supports are simply supported. In that case, the bending moment there will be zero, and if suppose the end is fixed, there will be friction moment, and in that case, slope will be at this fixed end will be zero. So moment of inertia, whenever we want to calculate the moment of inertia of the beam, So in different span, it may be same or maybe different. So it depends upon the span, how that span is, and it totally depends upon it. So if suppose if we just take this one, and if we just draw simply supported bending moment diagram for this beam, in that case it would be like this. And if we just consider this as, let us take this one is positive one, and this is nothing but the simply supported bending moment diagram. While if we just consider there is a fixed end at point A and C, in that case we can say that there will be fixed end moment, and this would be like this. So this would be like this. So let us say this as MA, MB, and this one as MC. So suppose what we are considered, this is the continuous beam, and in the continuous beam there are the more than two supports. Just like here, there are three supports A, B, and C. Now, whenever we want to consider this as let us first of all calculate the bending moment diagram to be simply supported and fixed end moment diagram. This one is the fixed end moment diagram. So these are the two different diagrams you need to draw, and based on this, there is a theorem which is by a Clapeyron's theorem. Clapeyron's theorem. This is basically three moment theorem is also it is called as three moment theorem. So if we just consider, we will directly go on for the form of that particular equation, or what is that per theorem that we will see. So suppose there is a beam with same moment of inertia, for different span. So what does this mean? It means that the I1 would be I2, or that would be simply I in that case. Now in this case, we got here MA, we got here MB, and this one is MC. And then this A1, let us consider this as A1 and this as A2. A1 and A2, they are the area of the bending moment diagram for the simply supported load, considering the case. Now, in this case, if we just consider this as, let us take this one as x1 and this one as x2. X1 and x2, they are the distances of CG for area A1 and A2. Now, what does this Clapeyron theorem say? So, the Clapeyron theorem suggests that this the MA into L1 plus twice MB into L1 plus L2 plus MC into L2. and this is going to be equal to minus 6 times a1 x1 bar, which is this one x1 bar and x2 bar, divided by L1 plus A2 into X2 bar divided by L2. So this one is the Clapeyron's theorem. This one is the Clapeyron's theorem, and this is also called as free moment theorem. When I1 equals to I2 equals to I. So you can just draw this one and write down this equation. I'll give you just 1 or 2 minutes for this. So this was the case for the Clapeyron's theorem of free moment. I suppose you might have written the equation now. That will be required whenever we want to solve a problem. So apart from that, if there is a continuous beam with end support is a fixed, in that case also we can use this equation. So suppose there is a continuous beam with end support fixed. With end support is a fixed one. So in this case, suppose this is a fixed one and there is a one support over here. Now because of this, let us say this as A point, this is the B point. So because of the fixed support, you will have the moment here, and this moment will also be at this point B. So if we just draw a bending moment diagram here, so it would be like this. Let us take this as area, and you will have this x bar as the distance of CG. And similarly, if you just draw the fixed end moment diagram, in that case, it would be MA and MB. So this is how you will get the fixed end moment diagram as well as the bending moment diagram. So if there is a continuous beam and there is a fixed end support, in that case, we will get twice MA plus MB equals to minus 6 area into x bar divided by L. So this is how you will get the equation. Will get this equation 2 times MA plus MB equals to minus 6 A into x bar divided by L. Now in this there is a overhang. Now what we got, suppose there is a overhang now. Suppose there is a continuous beam with overhang on the one side. So what is to be done? So if there is a overhang, what does that mean? It means that suppose this is a diagram. You have this continuous beam and this one is the overhang. So let us take this A, B, C and this one as B point. So for this case, we will get bending moment diagram like this. And for this, since this is an overhang, we will get like this. Let us take this as A1, this as A2, and you will have this X1 bar and this as your X2 bar. Just consider this as moment C, MC. So because of this, the formula would be MA into L1 plus twice MB into L1 plus L2 plus MC into L2, which would be equals to minus 6 times A1 X1 bar divided by L1 plus A2 X2 bar divided by L2. So this is how you will get these three different equations. So we will see that so tomorrow we will solve the problem related to the continuous being. So you can write down your name and the roll number in the chat box if you are not written, and then we will end the meeting here.